In this video, we're going to look at the hydration of aldehydes and ketones and some of the specific details that we need to think about. So in this reaction, we always need to be concerned about equilibrium conditions. As an equilibrium reaction, this one in particular is going to favor the carbonyl or the reactant. So it's not always easy to get to the products. You have to do something to really push it towards products. So it's really not a great way to form an alcohol from the carbonyl. So if you have options, this probably wouldn't be your best choice. Typically, when we think about hydration, what we're adding is water. However, we could really be adding anything that has a hydrogen that is attached to something electronegative. So something like an alcohol, water, obviously, something like an alkyl halide, where we're talking group 7, HCl, HBr. Those could be added as well as the water specifically. This reaction can be acid or base catalyzed. And then what we're really producing here are diols, especially if we're adding water. If we're adding another alcohol or an alkyl halide, then you're going to produce an alcohol with either an ester or a halogen adjacent to it. So let's look at an example of hydration. So I'm going to start with a ketone, but it will work the same for aldehydes. So if we do acidic conditions, water, when it's already got acid mixed into it, really exists as H3O+. We said earlier that if you're under acidic conditions, one of the first things you're going to do is protonate. So if I protonate first, we're going to add that hydrogen to the carbonyl oxygen. Which means I then produce water. That water then becomes your nucleophile and attacks the carbonyl carbon, that electrophilic carbon. I now have the alcohol as well as the water attached. That water is now positively charged. There's 3 bonds to oxygen. And because we're in acidic conditions, what will happen is another water molecule will come by and remove the hydrogen from where the water added. And what I now have is the diol. So 2 alcohol groups are attached to the carbon that used to be the carbonyl carbon. If I instead want to do this in basic conditions, typically then we're dealing with hydroxide. This is now a good nucleophile. In acidic conditions, I didn't have a great nucleophile. Water's not a great nucleophile, it's neutral. But I did have a really good electrophile. So I have the resonance structure stabilized carbonyl, where that carbon with the positive charge on it is a little bit more dominant than it is when I don't have the protonated version. With the basic conditions, I have a really good nucleophile. So what it's going to do is it's going to attack that carbonyl directly, kick up those pi electrons to form the tetrahedral intermediate. I'm in basic conditions, so having a negative charge is perfectly fine. I have the alcohol attached now since the base added. And what I just need to do now is protonate as my last step. So I still have water floating around. So I will protonate, and I can produce hydroxide here again because I'm already in basic conditions. So I end up with my diol right here. So the fewer steps, one's not necessarily better than the other. For the acidic conditions, the way you would write your reagents, any kind of acid, something like sulfuric acid in water, those are the reagents that you would use. In basic conditions, to get that hydroxide, something like sodium hydroxide in water, aqueous sodium hydroxide would work. So that's your hydration of aldehydes and ketones.